Today I'll talk about Moody diagram, and today I'll also show you how to read Moody diagram. Then I'll solve one numerical problem using Moody diagram. Now here is the problem. Find the head loss of water due to friction in a glass pipe that is 12 meter long and has a diameter of 15 mm. Using Moody diagram and the Darcy-Weisbach equation for the following velocity, we have to calculate what is the head loss. So number one, velocity, when velocity is 0.125 meter per second, what will be the head loss? And two, when velocity is 1.25 meter per second, what will be the head loss? Now here the Darcy-Weisbach equation is given, that HF is equal to FD L by D B square by 2. That is given. Now first I have to know what is Moody diagram. This is the Moody diagram. Here x-axis represent Reynolds number, that is R is equal to rho V dV by mu, and then right hand side, that is represent relative pipe roughness epsilon by D, and that left hand side is the friction factor. So here if I know the Reynolds number and okay, so here different zone is actually there. So first zone is when that Reynolds number less than 2000 and F is function of RE, that is F is equal to 64 by RE. So from this region, if I know the Reynolds number, I can easily find that friction factor, or we can directly use F is equal to 16 by RE, so we can easily find the friction factor. Now zone when RE less than 2000 less than RE means RE range between 2000 to 4000, so F is difficult to determine. So this region is that the transition region. So that Reynolds number is 2000 to 4000. Now after then greater than 4000, that friction factor is function of RE and epsilon by D. So now in that greater than 4000, if we calculate, if you want to calculate the friction factor, so we must know Reynolds number and epsilon by D. Now this is all about the Moody diagram. Now here is the problem. Find the head loss of the water due to friction in a glass pipe. So here pipe is glass pipe and that 12 meter long and has diameter of 15 meter. So using Moody diagram and the Darcy-Weisbach equation for the following velocity, V is equal to 0.125 meter per second and V is equal to 1.25 meter per second. So I told you, so if we want to calculate friction factor, so first we have to calculate Reynolds number. So now we have to calculate, so before that, so this is the Darcy-Weisbach equation. So HF is equal to F L by D square by 2G. If G is not there, so then unit will be different, as here this is that HF is in the head loss. So head loss due to friction, so in meter, and F is the friction factor from the Moody diagram, and L is the length of the pipe, so that is given 12 meter, and D is the diameter of the pipe, so that is also given 0.015 meter, and V is the flow velocity meter per second, and acceleration due to gravity is 9.81 meter per second square. Now first we have to calculate Reynolds number. So we know the Reynolds number is nothing but rho B D by mu. So rho is the density of the water, so that is 1000 kg per meter cube. B is the flow velocity meter per second. D is the diameter that is given, diameter of the pipe 0.015 meter, and mu is the dynamic viscosity. We can take 1 into 10 to the power minus 3 Pascal second. Now here, so first condition V is 0.125, so we are going to find out the Reynolds number. So rho, this is 1000, rho, then V is 0.125, and then D, and then mu. So RE is for this velocity, RE is nothing but 1871.25, and when V is equal to 1.25 meter per second, so obviously if you see here, so that is I think 10 times. So here that Reynolds number will be 10 times. So again RE is equal to 1000, then velocity, then diameter, then viscosity, so that is 18712.5. Now here, so in our problem So we choose, we have that glass pipe. So here glass pipe, so if you see here, so glass pipe epsilon is glass and plastic, so that is given, so 0.0025. so that is rough, epsilon is given, that surface roughness is given. So now we have to find out the ratio. Okay, so ratio is something like that relative roughness epsilon by d. So epsilon is 2.5 into 10 to the power minus 6, because that epsilon is 0.000025 mm. So now we have to convert into meter, and then d is 0.015 meter. So we'll get 1.67 into 10 to the power minus 4. So now this value will and Reynolds number will use, and we'll find the friction factor. Now here, so first case, so that RE we got here, so RE is 1871. So this is the RE. Okay, so now here is the line, and that 1871. So maybe we are taking the approximate things. Okay, now this line is nothing but the laminar flow line, so that will cut here. Okay, and then so if we go to the left hand side, the horizontal line, so that will cut here, so that will give the friction factor. So that friction factor is 0.0345. For Reynolds number RE1871, so from the Moody diagram we will get that friction factor is 0.0345. Now RE is 10 times higher. So first we have that E by D, that is 1.6 into 10 to the power minus 4. Okay, so from here, so these are the that E by D the line. So now we are just take some line in between. So from line we'll start from here, the nature of line we are plotting. Okay, now next, that Reynolds number we already calculated, so that is 18713. I'm taking the round figure, and this is the approximate 18713, that horizontal line, sorry, vertical line I'm plotting, and that will cut here. So now from here, if I draw the horizontal line, so that will give my friction factor. So particular Reynolds number 18713, and epsilon by d is 1.6 into 10 to the power minus 4. So that friction factor is 0.0276. Now after getting that friction factor, we can easily calculate the head loss. So now here, that another way we can, for the laminar flow, you can easily calculate the friction factor, that is 64 by RE, and that 187125. So we calculated that friction factor is 0.0276. Now for that okay, so for using that 16 by RE, so we got that Reynolds number is 0.0342, and from Moody diagram we got 0.0345. so that is nearly equal. Okay, nearly same. And for that Reynolds number for V is equal to 125, or Reynolds number for 187125, that friction factor is 0.0276. Now if we want to calculate the head loss for V 0.0125, so we will use Darcy-Weisbach equation, that is HF. Okay, so HF that F, this is F, L by D, then B square by 2 into G. So that is nothing but 0.0176, and this is actually the friction factor we calculated. F from F is equal to 64 by RE. Okay, now that is 0.0176 meter. Now HF, if we take that Moody diagram, and if we calculate that, so that is 0.0176 meter. And when V is equal to 1.25, that head loss for V, that is again F, L by D, and B square by 2G. So that is 1.758 meter. So that's it, I think.